Hello, my name is Austin Tavares. I'm currently enrolled in the CS 112 class here over the summer at Allen Hancock College for the 2024 year, and we are going to solve an extra credit problem here called Weird Sort. Now, I'm basically just going to go ahead and analyze this algorithm, basically tell you what it does, and we'll just go line by line and see how it does that. But first, before I do, let me run the program to make sure it actually does what it's supposed to do. So given a file, basically, we're just going to sort this file of numbers in order from lowest to highest. So let's see how that goes. 2, 3, 5, 6, and 7. So there you go. Magically sorted this file into the proper order and displayed it to standard out. So that's a great thing. So now let's just actually walk through it. We have a try-catch block here that takes an IO exception, basically prints an error message. This is important because we are dealing with files later on into the code that I will explain when we get there. But moral of the story, all this is going to do is check if the file is there, or if something bad happened while we were parsing, or some other extraneous error, something like that. So we'll just leave that for now. So now we have a range-based for loop, and this for loop basically states we give it a path, like a raw string literal, and that gets converted into an actual file path, which then that file path gets passed into a stream that basically reads the current line. So basically this line is being read, 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 and so on. So now we're taking those raw string literals of the numbers, which are already down here, so I'll just go ahead and move them up here. We're going to take the raw string literals of each of these numbers and convert them into an integer. That's basically what this map to int method does. It takes a lambda expression, which by here we have parse int, which is a valid expression, and we're taking these string literals and we're turning them into actual binary digits, which I don't really know how to show that, but I can just say this is a good representation. And now we're shoving these binary digits into an actual array data structure, which can be iterated over using the range-based for loop. So once we step into the code, we can see that a new thread is being created. Now a thread is basically a single instance of your program, essentially. I should elaborate first that we didn't really learn concurrency at all in this class. This is all just kind of like my own little private research that I've done for the past couple of years because I'm into the operating system stuff and worlds and low-level memory management and all that stuff. So let me go back to explaining that a thread is basically just like a separate instance of your program or data that gets ran every time, except it's not a separate program. It's a strand of this. I don't even know how to describe it properly. I'm thinking of processes too much. I just want to call it a separate process, but we know threads are not processes, so I'll just leave it at that. But this thread is being created, and for each integer inside the array, let's just go ahead and copy these again. We're basically putting the thread to sleep for the current time in seconds. So how is it converted to seconds? Well, let's figure it out. The sleep method here by default takes milliseconds as the value to sleep for. So if we multiply 1 millisecond by 1000 milliseconds, it basically converts it into 1 second. So if I multiply 5 times 1000 milliseconds, that basically tells it, hey, go to sleep for 5 seconds. And so on with everything else. 3 seconds, 2 seconds, 6 seconds. So this is an important part right here for the sorting algorithm because we're printing out the current value. But it's not going to print it out right away. As we see, it's sleeping for this current amount of time. So when I say, oh, fall asleep for 5 seconds, this value isn't going to print until 5 seconds are up. So that kind of explains why it takes so long for these numbers to print, because, oh, we're falling asleep for 2 seconds. We're falling asleep. for 3 seconds, 4 seconds, and so on. So that's the main reason why it sorts it in order. And this would actually work for multiple different numbers. So if I did a list of 10 integers that were randomly jumbled, it would sort them in order until their time has, until the thread is awakened. Now, this is a great example of a data race and why this can lead to undefined behavior if this was a different program. But since this is a joke program or a little silly program that's weird, it's okay to let the threads kind of execute out of order. It's whatever. They'll end up in the same location anyways. However, you would usually not want this to happen when you're dealing with real programs. So I've kind of created a subclass that sort of demystified this, and I actually broke the program a bit to do so. So I added some mutual exclusion to this to sort of force the program to say, hey, don't continue to the next thread until this current thread is finished. So we added a mutex here, or a lock, or whatever you want to call it. And basically, we're putting this thread within this region, and we're basically saying, hey, you can't leave this thread until time is up. So let me go ahead and copy this list so we can sort of explain this in better detail. So as you see, when I run this program on demystified, or the broken program variant, this thread isn't going to execute until 5 seconds is up. There you go, 5 seconds. Now 3, it's going to be a little bit quicker. Now 2. But now we got to wait a whole 6 seconds just to print the value. This is one of the important concepts of concurrency, is, making sure that each thread finishes their work before joining back to the main thread. So bam, there you go. We can see that they are all printed in the same order that they were read from. So that's sort of the mystery behind the weird sort. It basically doesn't do much besides, hey, just print after 7 seconds, print after this many seconds, etc. So I'm just saying it's a weird sorting algorithm, but at the end of the day, it does its job, and it's pretty good for what it does. So that's it.